Hello, this is Mr. Win, and this video is about factoring polynomial expressions, part 1. This is an extremely important video, so make sure you take very good notes. So factoring is a method that makes hard problems very easy to solve. It will turn a problem with multiple terms being added or subtracted into a single term multiplication problem. There are 5 methods of factoring that you have to know. The first one that you always have to do is the GCF method. That's the greatest common factor. It's what can you take out of all the terms, and I'll show you that in a second. Then you have to use a follow-up method depending on the number of terms left. If there's 2 terms, there's 2 other methods. You have the difference of squares method or the sum or difference of cubes method. If there's 3 terms, we use the guess and check method, and if there's 4 terms, you use a grouping method. But usually you have to use a combination of them. So you might do GCF first and then guess and check second, or GCF first and then difference of squares second. So the first one's GCF. Again, always do this first. First problem is 2x with 6. There's 2 terms. I check what can I take out of both of them, or what can I divide them by. I know I can take out 2 from both of them, so if I take out 2, what's left over would be x plus 3. And I could quickly check this by distributing. 2 times x is 2x, 2 times 3 is 6. But I went from a 2-term problem to a 1-term problem, because this is multiplication, 2 times that thing. Alright, so there could be a number GCF. This next problem, ab plus b squared, we could have a letter GCF. So what is in common both of them? They both have the letter b. If they had the same letter, you take out the letter with the lowest exponent. So I'll take out b to the first power. If I take out b, what's left would be a plus b. Again, you can check by distributing. B times a is ab. B times b is b squared. So we could have a letter GCF. We could also have a combination of a number and letter GCF. So this next one, 5x squared plus 10x, they both have a 5 in common. And they both have x in common. So 5x is a GCF. What's left over would be x plus 2. So again, 2 terms turns to 1 term. And you can check by distributing, which you don't have to do. We're basically undistributing. That's what factoring is. And the last one's 3 terms. They all are even numbers. 2, 4, 8. I can take out 2. They all have the letter x. The smallest x minus c is 1. So 2x to the first power is my GCF. What's left over would be x squared plus 2x plus 4. And that's it. Alright, so that's GCF. The next method is actually more like a formula with the difference of 2 squares. And it's that formula. There's a sum of 2 cubes as that formula, and difference of 2 cubes as that formula. And actually for the sum and difference of 2 cubes, all those 2 different formulas, we combine to one by using this SOAP, the SOAP acronym. Alright? The S stands for same. So if I do the sum of 2 cubes, it started out as a positive sign, right? So the first sign would be positive, plus. The O stands for opposite. So opposite of plus is minus right there. And the AP is always plus, or always positive, so that's a plus right there. So for sum of 2 cubes, the signs for the parentheses will always be plus, minus, plus. Same idea for the subtraction one. So it starts out subtraction. So same with subtraction is still subtraction. Opposite of subtraction is plus, and then opposite AP is always plus. Alright, so for difference of 2 cubes, the formula or the signs inside the parentheses will always be minus, plus, plus. Alright, now when we actually do these problems, we just have to find the value of a and b and fill in the formula. The shortcut to seeing to this is to see if you can either square root both terms or cube root both terms. So make sure you know your perfect squares and perfect cubes. This next slide has all the common ones. For example, if I see the number 9, I know I can square root 9. Square root of 9 is 3. If I see the number 81, I can square root 81. I know that square root of 81 is 9. So y'all should know the perfect squares. The cubes might be a little harder, but if you see the number 27, you can cube root that, because 3 times 3 times 3 is 27. Or if you see 1,000, you know the cube root of 1,000 is 10, because 10 times 10 times 10 is 1,000. Just make sure you can recognize those numbers. Alright, so now let's try the problem. So factor via difference of squares only works if there's 2 terms. Again, you check GCF first. For the first thing, there is no GCF, x squared minus 4. So I'm going to see if I can square root them. So can I square root x squared? What times itself is x squared? Well, x times x is x squared. Can I square root 4? Square root of 4 is 2. We just found the a value and the b value. So going back to this, the formula is once you know a and b, you just make 2 parentheses. I'm going to rewrite this. You put the a term at the beginning of both, put the b term at the second part of both, and have a plus sign and a minus sign. That's the formula. Alright, so I'm going to do that for our problem. So, one more. I make two parentheses. For the first part, I'm going to put a. Now a is actually x. I'll put x here, and x there. Then on the right side of each parenthesis, I'll put a b, which is 2. So I'll put a 2 here and a 2 there. The signs are always plus and minus, and that's it. If you FOILed that, you actually get x squared minus 4. Because that's the difference subtraction of two squares. Alright, next problem, same idea. There is no GCF. I have to check first. I can't take anything out of 9 and 64. I'm going to see if I can square root them. It is different, so subtraction, that's good. Square root of 9x squared. What times what is 9x squared? Was 3x. It squared the number. Square root of 9 is 3. And square root of the letter. X squared is x. And square root of 64 is 8. So we found the a term and the b term. I make two parentheses. Put the a term first. 3x, 3x. The b term second. 8, 8. The signs are different. Plus, minus. And if you FOIL that, double distribute, you'll get 9x squared minus 64. This next one, a lot of kids get wrong because they say you can't square root 50 or 8. But remember, you have to check GCF first. I can take out 2 from both of those because they're both even. If I take out 2, what's left over would be 25x squared minus 4y squared. Now this is actually a combination problem. So the inside of the parentheses is 2 terms. It's subtraction, that's the difference. And I see x squared and y squared. Those are perfect squares. So I'm going to try to square root both of these. If I square root both of these, square root of 25x squared will be 5x. Square root of 4y squared will be 2y. And I find the a and b terms. So now my final answer will be, well, the 2 stays outside, that's a GCF. I make two parentheses. The a term is the beginning of both, so 5x, 5x. The b terms are the end of both, 2y, 2y. The signs are plus, minus. If you multiply that all out, you'll get the original problem. All right, one more. That's x to the 4th minus 16. I check for GCF. There's something I can take out. It's 2 term subtraction, so I'm going to see, is that difference of squares? Can I square root them? If I try to square x to the 4th, well, what times itself is x to the 4th power? Well, it's x squared. X squared times x squared is x to the 4th. Square root 16, oh, that's 4. We found the a term and the b term. So I fill in the formula. A term first, so x squared, b term second, 4, 4. The signs are plus, minus. Now this is actually a famous problem because we're not done. You have to check the parentheses if they can do anything. The first one is x squared plus 4. That's a sum of squares. We can't really do anything with that. But the second one, x squared minus 4, that's another difference of squares. That's actually the same problem we did right here, the first problem. So I can go and do square root again, square root again. Square root of x squared is x, square root of 4 is 2. So I found another a and b. So that this first parenthesis stays the same, x squared plus 4. The second parenthesis turns to 2 new parentheses. The a terms at the beginning, x and x. B terms go to the end, 2 and 2. Plus sign, minus sign. Alright, so that is the full answer for the last one. If you multiply all out, you'll get x to the 4th minus 16. Alright, when you do the sum and difference of cubes, it's very similar to that last one. So again, only for 2 terms. You check for GCF. X cubed minus 8 does not have a GCF. I try to square root them. I can't square root x cubed. I can't square root 8 either. So I try to cube root them to find my a and b terms. If I cube root x cubed, what times itself is x to the 3rd power? Well, that's x. I try to take the cube root of 8. What times itself is 8? Well, that's 2, because 2 times 2 is 4, times 2 is 8. We now found the a term and the b term. For the difference of cubes formula, so go back here, it has 2 parentheses, a short one with a and b, and a long one with a squared plus ab plus b squared. Alright, so we have to create 2 parentheses, a short one and a long one. So here's how I'll show it. Short parentheses and a long parentheses. In the short one, we have 2 terms, one right here, one right here. In the long, we have 3 terms, one right here, one right here, one right here. So for the short parentheses, the small one, you just put a and b. So a is x, b is 2. For the bigger one, the first thing is a squared. So the first thing times itself. So x times x is x squared. The middle term is this a times b, or the 2 things multiply each other. So x times 2 is 2x. And the last term is just b squared, or the second thing times itself. 2 times 2 is 4. Now I need the signs. That's why I use the SOAP formula, S-O-A-P. So S is same. The problem started as a subtraction problem. It stays subtraction. Opposite of subtraction is addition. Then always plus, always positive. That is the final answer for the first one. So I'll box that in. Alright, same idea for the second one. So I check for GCF, none. I try to square root them, doesn't work. I try to cube root them, if you see a third power, you probably want to cube root. This is a difference because there's a subtraction sign. Cube root of 64 is 4. Cube root of x cubed is x. Cube root of y cubed is just y. We now find our a term and our b term. I make the formula. Short parentheses, long parentheses. A is 4x, b is y. Alright, so that's the short one done. For the bigger one, it's the first thing times itself, a times itself. 4x times 4x is 16x squared. The middle term is a times b, so the two things multiply each other. 4x times y is just 4xy. And the last thing is the last thing times itself, b times itself. Y times y is y squared. Can I use SOAP? Same, opposite, always positive. It was originally a subtraction problem, so same as subtraction is subtraction. Opposite of subtraction is addition, then always plus. So this right here is my answer. If you try to multiply that, double distribute, or triple distribute, you get the original problem back. Alright, this next one down here, I check is there a GCF. There's something in common between 27 and 125. I see a third power, so I'm going to try to go ahead and cube root them. Alright, cube root of 27 is 3, cube root of a cubed is a, cube root of 125 is 5. I found the a term, I found the b term to plug into the formula. So I make the two parentheses, a short one and a long one. A goes first, b goes second, a times itself. 3a times 3a is 9a squared. A times b, 3a times 5 is 15a. And then b squared, b times itself. 5 times 5 is 25. I use a SOAP formula again. That just helps us fill out the signs. Right, it was addition problem in the original, so it stays addition. Opposite of addition, subtraction, and then always plus. That's the answer for the third one. And this last one, a lot of people get confused because they forget you have to do GCF first. With a GCF of 2m to the fourth plus 16m, I see they're both even. I take out 2. They both letter m, so I take out m. The lowest exponent is 1, so I take out m to the first power. What's left would be m cubed plus 8. Alright, now I can check that inside. I see two terms. I'm going to see if I can do different squares, but it's not subtraction. Or if I can do a sum or difference of cubes. It is cubed and it's sum, so I'm going to try to cube root them. If I cube root m cubed, I get m. If I cube root 8, I get 2. I find my a term and my b term. So I make the two parentheses. Use blue. Well, actually, there's two m's to the GCF in front. Then I'll make the two parentheses, the short one and the long one. Alright, so a goes first, that's m. B goes second, that's 2. Then m times m is m squared. M times 2 is 2m. Then 2 times 2 is 4. The signs are SOAP, same, opposite, always positive. Inside the parentheses is a plus sign, so it stays plus. Opposite plus is minus, and then always plus. That's the answer for the last one. Alright, that's it for this first part. I hope you enjoyed the video. Make sure you take good notes and ask any questions in class. See you soon. Thanks again. Bye.